Hello and welcome to OSDR Chats. Parkinson's disease is an important research area on Earth. Well, what about spaceflight stressors that lead to similar symptoms? A recent study found that astronauts might face such movement issues, brain changes, and cell energy issues similar to the disease, raising concerns about long-term spaceflight missions. Today, we're joined by Dr. Nilufar Ali of Boise State University, who will share with us insights about this topic based on spaceflight data and a glimpse into how the OSDR contributed to this publication. Thanks for joining us today, Dr. Ali. Could you please highlight the most important finding in your study?
Hi, Jennifer. Thanks for having me here. The key highlight for the paper is first the mitochondrial dysfunction that we see in spaceflight owing to oxidative phosphorylation dysfunction. That is exactly overlapping with the oxidative phosphorylation dysfunction that we see in Parkinson's disease or PD. That's the first highlight, I would say. And the second would be this is the first consolidated study that provides a list of similarities between PD and spaceflight related condition, which includes molecular, anatomical, and physiological similarities.
Thanks for sharing those insights with us. That's very exciting. My second question for you is, what role did the Open Science Data Repository have in enabling this publication?
So I'll start this answer with the background or an anecdote. So this is very, like I was looking for applying for a NASA funding, and I stepped onto this landmark paper published by Villian and Afshin, the Cell paper. So I was surprised to learn that mitochondria is so heavily affected globally across species after spaceflight. And I study neurodegeneration, specifically Parkinson's disease, and mitochondrial dysfunction is a hallmark in that disease. So I looked into the Cell supplementary section, and I found this OSDRs, the data sets that were using human in vitro cells, which were space flown. And one of the figures in that paper suggests OxPhos from the GSEA analysis. So I reanalyzed those, and I found that, and even in the paper, it shows that the PD signals pop up. And I was like very curious, like what are these Parkinson's disease signals? So after reanalyzing the data set, I found that all the PD signals were mostly the oxidative phosphorylation signal. So I found a key set of genes which were overlapped with the spaceflight as well as with PD. So OSDR helped me a lot, and like the open the Cell paper helped me a lot for this perspective. And so I contacted Afshin, who is heading the multiomics AWG group. So there, after presenting the data set, I started a PD subgroup, and now we are analyzing a huge, like a large amount of data set from brain, blood, and dopaminergic neurons, space flown as well as in the ground, and collaboration with Michael J. Fox Foundation to check like the similarities in depth in the genetic as well as the molecular level. So yeah, of course, the AWG and OSDR is of great help in this.
Wonderful. That's great to hear about the collaborations that led up to this. Thank you for sharing your time and insights with our viewers. And to our audience out there, you can learn more about this work, how to join the analysis working groups, and access the datasets analyzed in this work with the links provided in the description section below. Thank you and have a wonderful day.